Our next fallacy is the fallacy of hasty generalization. Hasty generalization is just an inductive generalization that seems like a good inductive generalization. But in fact, if you're carefully inspecting the evidence does not establish that that generalization is at all likely to be true. So inductive generalizations generally have the same structure. You make observations about particular instances of a class or category of things. You make some observations there, and then you make an inference about every member of that class. So, for example, Professor Frank here has observed cats and mice interacting a few times. Based on those observations, Professor Frank makes an inductive generalization about all cat and mouse interactions. So cats don't get along with mice as a general rule based on the observations of specific interactions. So, for instance, the Power Rangers got banned in Canada because they thought children watching cartoons like this or shows like this would make the following inference. Violence seemed to solve problems for cartoon characters. Conclusion, violence must be a general solution to interpersonal disagreement. Now, the problem with this inference is that it's a fallacy of hasty generalization. If you observe a bunch of cartoon characters and how they interact, and you make inferences about how human beings in the real world should interact, you've made a terrible inductive generalization because cartoon characters operate according to rules that human beings don't. So if Itchy and Scratchy get into a fight and Itchy cuts Scratchy's head off, Scratchy dies in that frame, and in the next frame, Scratchy's brought back to life again. Itchy gets blown up, the next frame, Itchy's brought back to life again. So the rules about cartoon characters are completely different than the rules about human beings. Any inferences you make about how they interact with each other should not be transferred over. It's a terrible, unrepresentative sample, and hence it's a fallacy of hasty generalization. And so in general, whenever you're making an inference about a whole class of events, every member of this class has this property based upon observations of some of them, a sample from that class. Right? And the sample is too small, or it's not representative of the population, it's biased, or it's not randomly selected, things of that nature, then you're probably going to make a hasty generalization. And in fact, oftentimes, people will make hasty generalizations on the basis of what's called anecdotal evidence. So you hear about one or two concrete cases, and those concrete cases are real. And because we're used to concrete problem solving, because of the way we evolved, we will think that those concrete cases are representative without evaluating whether or not they really are representative or whether or not they constitute a large enough sample. Our next fallacy is the fallacy of false cause. There are really two ways to commit the fallacy of false cause. On the one hand, you could make an inference from some bit of evidence to there being a causal connection between two things, where that evidence doesn't really support the inference of the causal connection. So that's one way. I infer a cause on the basis of inadequate evidence. Another way is when you use a false cause, a cause that really isn't a cause. You suppose it's a cause and you use it to infer some other conclusion. So you have some evidence, you infer a causal conclusion when the evidence doesn't support it. That's one way. You use a causal connection that doesn't really exist to argue for some other conclusion. That's another way. So either way is a way of committing the fallacy of false cause. Now, there are a number of different varieties of this, number of different ways you might come to believe that something is a cause when it's not. And these are mostly traceable back again to British empiricism and the philosopher John Stuart Mill. So the first one is called post hoc ergo propter hoc. The idea is that it's temporal succession. The cause is followed by the effect. And so when you see two things, one preceding the other, you might be tempted to infer that there's a causal connection there. but not every temporal succession is evidence for a specific causal connection. So, for instance, I talked to Wallace right before the test and I failed. Talking to Wallace causes failure. I guarantee you that is not a causal connection. It's a temporal succession that is not indicative of a causal relationship. Next one, non-causa pro causa. This essentially says not a cause is a cause. The idea here generally is that you're making an inference of a causal connection based on a correlation or coincidence that you observe. So you might think, oh, I observe a lot of rich people, they seem happy. By the way, statistically not true, but say you make that observation. So long as I stay upbeat, then I'm sure to become wealthy because they're connected to each other causally, right? I mean, I see this co-occurrence, and so I make that inference. But again, co-occurrence can just be coincidence, right? The fact that two things tend to co-occur doesn't mean that they cause each other. Finally, oversimplified cause. In this case, it's our limitation in our working memory, the amount of information that we can actually hold in our heads. That is the source of our false cause. So we oversimplify the case. So we look at a case that's got a number of different factors that contribute to some effect, and we focus on a single one of them to the exclusion of all the others. We simplify it to make the problem more manageable. So you may think, hey, vitamin C keeps you from getting sick. By the way, not true, right? Once thought, possible, but not really. So you may say, look, as long as I take vitamin C, I can do whatever I want. I can lick doorknobs or run naked through ice storms or stay up all night on crystal meth or do anything that might undermine my immune system because I'm taking vitamin C. But of course, one causal factor isn't going to be the only thing that determines whether or not you get exposed to an illness or whether or not you're capable of fighting it off or get sick. And so when we have cases where we just focus on a single cause to the exclusion of others, we commit the fallacy of oversimplified cause. The last fallacy in this grouping of fallacies of weak induction is the fallacy of slippery slope. And it goes something like this. Right? First, like you turn in a homework assignment, then you get hooked on the high of intellectual achievement. You end up going to college, then graduate school. You end up getting your PhD in philosophy. And like you have no job opportunities and you laugh hysterically at jokes about logical fallacies. And your students and your coworkers and your family all despise you. This, of course, isn't biographical. But this is how slippery slope works. So in slippery slope arguments, we have an initial situation, an initial event. And that event is connected through a series of conceptual, ideological, or causal links to some event that is usually unanticipated and surprising, really. And so when you commit the fallacy of slippery slope, right, you're connecting these two events together for people by telling a story. Now, telling that story doesn't mean that it's actually likely that those two events will be connected in that way. If you tell a long causal chain, each link in that causal chain makes it a little bit less likely that the conclusion will eventually come to fruition. Every time you add a link in your chain, you introduce a way that the chain could fall apart. And so, for example, when you look at these Rube Goldfarb competitions where you create a bunch of machines that do things like, cook some eggs with 52 steps from a bunch of junk that your professor gave you, right? You can get a machine that does that one time. Getting it to do it consistently, that's the tricky part. And so slippery slopes, by relying on these elaborate causal chains, right, they're not actually making it more likely that the conclusion will be true given the initial circumstance. In fact, it's probably not very likely that things will happen just as predicted. However, right, because we can now see a way to get from that initial state to the end state, we tend to see it as more likely when we're told that story, even if the story is improbable and poorly evinced. And so slippery slopes can really suck us in. By giving us a way to imagine how it could happen, it then makes it more likely that it will happen for us, even though that way of imagining it may not increase the likelihood at all.